here's our band of stability, as we saw in that video, and it allows you to compare the number of protons and the number of neutrons and figure out if elements are going to be stable or not. So this one's simpler than the one that was in the video. Basically, these dots that you can see in here, these are going to be your stable isotopes. And the lighter elements, like for example, something that maybe has 10 protons, it also, if it has also 10 neutrons, it's going to be stable. So you can see that in the beginning, there's a 1-to-1 ratio of the number of protons to the number of neutrons and kind of their stability. But as it increases, you can see this is that 1-to-1 ratio. It doesn't really work out as well, meaning you need more neutrons for less protons for it to be stable. And then eventually they're just not stable once they get above 84, as they said in that, that video. Okay, so let's go through one of these kind of example problems in here. Okay, so if an atom has 20 protons and 60 neutrons, could it be stable? So all we have to do is plot these two things and then find out if it's on these dots. So we go from 20 up to 60. If we take a look, that's going to be about here. And we would say, no, not going to be stable. All right. Now, how could we make this stable? I know it's not what it's asking, but we would have to reduce the number of neutrons until it falls into that band. And this is 20. And if we look at about 20, we can see that it would be stable if they both had about 20 in there. So 20 protons and 20 neutrons. All right, let's check out the next one. It says, if an atom has 55 protons and 80 neutrons, could it be stable? So 55 is in the middle here. And then 80 is here. And if we kind of see that putting them together, it is close to the edge of that stability, but I would say it's still in there. So yeah, we could say, sure. Why not? Could it be stable? Yeah, it could be. All right, how could you make an atom stable? What would you need to do? And this actually goes back to what we talked about in this first one, where it was at 60 and 20. And what did we do? We reduced the number of neutrons to bring it to that stability, the band of stability. Now, if it was underneath, you would increase the number of neutrons to bring it up to that band of stability. So that's kind of what you would need to do, which would be change the number of neutrons. Okay. All right, before we move on, does anyone have any questions with that one here? Okay, so these are some other problems very similar to what we just did, but just slightly more complicated. So it says, determine the identity of the isotope and write its nuclear notation. So we need to talk about nuclear notation real quick because we haven't really this year. So first of all, if something has 20 protons, what element is it? And so I'm going to look on my periodic table and I'm going to see that 20 is calcium. And if you remember, there can be a number at the top and a number at the bottom. So this would be the mass number, which is a combination of your protons and your neutrons. And then the bottom one is just your atomic number or your number of protons. So for calcium, calcium's always going to have a bottom number of 20 because it's always going to have 20 protons. Now, what they're telling us here, and this is the hyphen notation, and they put an X here because they didn't want to give away that it was calcium. So what it would actually look like is calcium dash 60. All right. And this 60 is representing the top number, which means that the 60 is the protons and the neutrons together. All right. So that's all information about what we're given here. And it says determine if the nucleus is stable or unstable. Now, before we can do that, we need to know the atomic number, which is the number of protons. And then we need to know the number of neutrons. So from this information, we know that we have 20 protons. We know that we have 60 protons plus neutrons. So if we just subtract, we'll end up with 40 neutrons. All right, everybody cool with that so far? All right. Okay, so let's plot this out. Now that we know the number of protons, well, we were given the number of protons, but now we know the number of neutrons as well. So we have atomic number of 20. So I'm going to put a little mark right here. And then we're going to go up to 40. And then we'll cross here. And we'll see that it looks like it's outside of that band of stability. All right. Which it makes sense because it's a lower number. So we would expect it to be kind of 20 and 20, you know, even. So I would say that this is not stable. All right. Not stable because it ends up being right here. All right. So the last part of this is it says if it's unstable, how could it become stable? Well, what I would do is like what we were talking about before. I would remove some neutrons. So how many neutrons would we remove? Well, we want to get it down to about maybe 20, because 20 is kind of, that's in there. That's kind of the easiest one I would see. There's a lot of options for this. You could say maybe 23, 24, anywhere where it still kind of falls within that band. But I'm just going to go with 20 because it's a nice round number. Again, you can have different answers. That's fine. So what I would do is I would remove about 20 neutrons. So then it would only have, 20 neutrons and then 20 protons. And that's kind of how I would do this first problem. Okay, are there any questions in general about how I figured out these different things? So you would do the same thing for the other ones. All right, we have just enough time. Let's try the next one. All right, so if we look on a periodic table, there's 50 protons. So if we look for 50 on the periodic table, that's going to be Sn, that's going to be 10. We know the bottom number is going to be that 50, right? And then we also just learned that the top number is going to be that 70, because that 70 represents both the protons and the neutrons. So 70 is both of them. And then we're going to minus the 50 protons, because again, we're going to try to figure out the number of neutrons. And then here we're going to end up with 20 neutrons. And that seems like a low number considering you have 50 protons. So I'm going to come over here where the 50 is. I'm going to go to 20. And we can see that it is way under that stability. So for this one, I would say also that it's not stable. Let's see, what was the next question? So it's not stable. We need to figure out how to make it stable. So we can't change the number of protons. So we need to keep going up until we hit this band. And again, I'm looking for nice round numbers. So I'm going to go with anywhere around 70 seems like the number of neutrons we would need. So let's add, we already have 20, right? So let's add 50 neutrons. So we'll add 50 neutrons. So it'll be 20 plus 50. We'll get 70 neutrons, and that'll make it stable.